Alright, in this video we're going to talk about section 1.7 day 2, using inverse trig functions. So before we talk about using inverse trig functions, let's talk about inverse functions in general. So inverse functions have the property, if we remember, that f of f inverse of x equals x, and f inverse of f of x also equals x. So that's going to apply to our inverse trig functions. So sine and arcsine, so sine and inverse sine of x is equal to x. Arcsine of sine of y is going to equal y. Cosine of arccosine of x equals x. Arccosine of cosine of y equals y. Tangent of arctangent of x equals x. Arctangent of tangent of y equals y. But then you'll notice this note that I have down here. When using these, we need to keep in mind the intervals on which x and y can be. As this this will not work for all numbers. So for all numbers, our little rules up there isn't going to work. It's only going to work for a certain set of numbers. The set of numbers where x is between -1 and 1, and where y is between -pi/2 and pi/2 for sine and tangent, and 0 to pi for cosine. And then x can be any real number for tangent. It's only going to work on those because we had to restrict our domain and range of the inverse trig functions. So we have to keep in mind all of these things in order to be able to use these properties, right? If our tangent and our arctangent are going to cancel out, the y value here, the y value there has to be between -pi/2 and pi/2. If our sine and arcsine are going to cancel out, this x has to be between -1 and 1. So it matters where your sine and where your arcsine are. So you'll notice sine's on the outside here, so our number here has to be -1 to 1. Our sine is on the inside here, so our numbers have to be between -pi/2 and pi/2. And that's going to be because our answers have to be certain things for the arcsine and arccosine and arctangent. So we'll look at an example and kind of show you what I mean. So if possible, find the exact values of the following. So the first one is the tangent of the arctangent of -5. So we have to think, do the tangent and the arctangent cancel each other out? And are we left with just -5? So the two ways we can do this is you can just memorize all 6 things in that table that we just made, and if you do, you can see that if tangent's on the outside, what you're taking the arctangent of has to be a real number. If it is, then we are left with just that real number, so -5 is in fact a real number, so our tangent and arctangent are going to be canceling each other out. Another way you can think about it, this piece here, the arctangent of -5, that's just saying what angle has a tangent of -5? Well, can an angle have a tangent of -5? If we think about the graph of tangent looks like that, so we can get a y value of -5. We don't actually need to know what that theta is, because this is saying what is the tangent of the angle whose tangent is -5. Well, the tangent of the angle whose tangent is -5 is -5. That's what this is saying. So as long as we can find an angle who has a tangent of -5, we know its tangent is -5. So that's the canceling each other out part there. For this next one, it wants to know arcsine of sine of 5pi/3. So we have to think, does this cancel out? Are we left with just 5pi/3? And we're not. Because if you remember, arcsine's answers have to be between -pi/2 and pi/2. So if we think about a unit circle, -pi/2 is down here, pi/2 is right there. 5pi/3, while it's in quadrant 4, we had to go through quadrants 2 and 3 to get there. So we can't really get that answer. So how we want to think about this one, since we know it's not just going to cancel out and give us 5pi/3, we need to think, well, what is the sine of 5pi/3? The sine of 5pi/3 is going to be -radical3/2. So then we got to think, all right, arcsine of -radical3/2. Well, we can kind of cheat because we know that if we go around this way, it's 5 pi over 3. And we can get its coterminal angle. If we start here and just go to that same spot, we know it's negative pi over 3 because we have to stay on this interval here. So we know that's going to be negative pi over 3 for our answer. So in this one, they don't just directly cancel each other out, but we can use the coterminal angle and then kind of cancel them out. So negative pi over 3 is going to be our answer there. For C, cosine of arc cosine of pi. So we got to think, well, is this right here possible? So is there an angle whose cosine is pi? And the answer to that is no, right? Because we think about cosine. Cosine is going to go from negative 1 to 1. Pi is bigger than 1, so this fits out. So there's no angle ever that's going to have a cosine of pi. So this does not exist. And again, this is coming back to if you memorize the table on the previous page, if cosine is on the outside, the inside number, the x number, has to be between negative 1 and 1, and pi is not. So that's one way we can do these, when they cancel each other out. Another way is if they give us something like this. Find the exact value of tangent of arc cosine of 2/3. Well, we're kind of stuck, right? We can't cancel a tangent with an arc cosine. But what we can do, again, is think about what the arc cosine of 2/3 means. That means there's some angle whose cosine is 2/3. And what this wants us to do is they want to know, well, what's the tangent of that same angle? So if cosine is 2/3, what's the tangent? Is really what this question is asking. So the easiest way to do that is let's just make a triangle. We can make a triangle who has an angle here that has a cosine of 2/3, right? So that means the adjacent to the hypotenuse is 3. And we can use our Pythagorean theorem to figure out this sides. This is going to be the square root of 9 minus 4. So we're looking at radical 5 there. So now we have the entire triangle. We need to find the tangent. The tangent of this angle is the opposite over the adjacent. So we know that the tangent of theta is radical 5 over 2, which means that the tangent of the arc cosine of 2/3 is radical 5 over 2. So again, remember, arc cosine just means there's some angle whose cosine is 2/3. What's the tangent of that angle? So we don't know what the angle is, but we can kind of work our way around it by making a triangle. So there's one more problem we're going to look at, and then we'll call it quits on the video. And it's this one right here. Write sine of arc cosine of 3x with the restriction that 0 or x is between 0 and 1/3 as an algebraic expression in x. So the key here is the fact that it's asking for an algebraic expression. This is not algebraic, this is trigonometric, right? We have trig functions, it's not algebra. You didn't see anything like this in algebra 1 or 2. So you can't keep it here. We need an algebraic expression. So it's really similar to what we just said a second ago. We're trying to find sine of some angle whose cosine is 3x. Right? So this just means there's some angle theta whose cosine is equal to 3x. Well, once again, we can make a triangle. Cosine is adjacent over hypotenuse. If I'm going to make this a fraction, I can make it 3x over 1. So we're looking at this and we're saying, well, 3x, the hypotenuse has to be the biggest side. Well, remember, x has to be between 0 and 1/3. That's why they put that there. So if x is between 0 and 1/3, this side's going to be shorter than this side here. So we want to know what the sine of this angle is. So we know sine of theta is equal to the opposite over the hypotenuse. So we know this is going to be something over 1. We just need to figure out what that something is. And we're going to do it just like we did a second ago. We can solve this right triangle, so we can say the square root of 1 minus 3x squared. So that's going to be the square root of 1 minus 9x squared divided by 1, which is just going to be the square root of 1 minus 9x squared. And again, we're not going to have to worry about taking the square root of a negative number because x is restricted to where that's not going to be a problem. So that's going to do it for this video. We'll see you in the next one.